Okay, so let's take a look at some of these review questions. So 72, graph y equals cosecant 4x. So we're going to start by graphing the reciprocal function, which would be y equals sine of 4x. Okay, so what's going on with this graph? The amplitude is going to be 1, our absolute value of the number in front of the sign, which is nothing, so just 1. Then your period is going to be 2 pi divided by anything in front of the x. So in this case, there's a 4 there. So our period is going to be 1/2 pi. Okay, and then this up here, there's your base graph for sine. Okay, so let's go ahead and sketch what our graph is going to look like. Okay, so if the period is 1/2 pi, we need to split that into fourths. So you have 1/2, and then 1/2 of 1/2 is 1/4. Then you have 1/8. This is 3/8. Okay, and then we do the same on the other side. Negative pi, or negative 1/2 pi, negative 1/4 pi, and so on. Okay, so your base graph starts at 0, goes up to the right. Okay, so I'm looking at that orange circled graph, right? Start at 0, up to the right. So we're going to do the same thing here. Start at 0, amplitude's 1, so we're going to go up 1, back to the center, down 1, back to the center. Okay, so this graph that I'm sketching now, when we finish the pattern, is the graph of y equals sine of 4x. Okay, well we want the graph of y equals cosecant 4x. So what you're going to do is go ahead and draw in the asymptotes everywhere we cross the x-axis. Okay, and then you're going to add our cosecant graph, which is just a little parabolas that go at every minimum and every maximum. Okay, so your cosecant graph is the purple. The blue is not. So I'm going to just erase it so it's not in our way. But there's your graph of cosecant 4x. So start with the reciprocal function first. And so now what we're left with, the purple part, is y equals cosecant 4x. All right, 73, graph tangent x plus pi over 2. So here, we'll highlight in pink, this is your basic tangent graph. Okay, so what's happening here is I'm adding pi over 2. If you're adding to the x, it's going to shift right or left. Since it's a plus, we're going to go left pi over 2. Okay, so let's start our graph just like the basic. And when I say left pi over 2, you have pi over 2. These numbers are going to stay the same. Okay, your period is not changing. Okay, but what's going to change is where the asymptotes are, right? Because so your normal graph, if I look at this highlighted pink one, I see I have asymptotes at pi over 2, negative pi over 2. Okay, so what's going to happen to ours? They need to shift left pi over 2. So instead of being at pi over 2, they're going to be at 0. So you're going to have 1 right here. The period is still going to be pi. So your next one over here is at pi. And then you have 1 here. And then the shape of the curve is going to be the same. So you have 1 here, another 1 here. Okay. And 84. Solve the equation on the interval of 0 to 2 pi. And I have cosine pi minus 1 equals 0. So we're just going to take that and solve for cosine. So add the 1. Cosine pi equals what? So we're looking for, where's the cosine 1? Okay, so it's going to come from your unit circle. Cosine number is the x-coordinate. So where do you have an x-coordinate of 1? Right here at 0. Okay, now it's also 2 pi, but notice in our question here it says the answer needs to be between 0 and 2 pi. 0 included, 2 pi not included. So just 0 would be your answer. So theta equals 0, and that's the only place you have a cosine or x-coordinate of 1.